Here with the black bird, I'm going to draw a picture representing what I see here. There's a block of zinc metal. Pictures are very powerful when you're doing problem solving. This is 4 inches. Labels are also very powerful. This is 4 inches. This is 12 inches. This could get you 192 cubic inches, but that's not very useful. It will be much more useful if you express these in centimeters. So that's something you can ask Google and say how many centimeters are an inch, and it's 2.54. So this becomes 10.16 centimeters. This becomes 30.48 centimeters. If you do then multiply length times width times height in centimeters, you'll get cubic centimeters. The number of cubic centimeters is 3,146. So it is not as simple as saying I will take the 192 and multiply by 2.54. That does not get you the right answer. No. Once you have this though, then you can say what mass of zinc is this? How many grams? Because then you can do chemistry. So 7.14 grams per 1 cubic centimeter. I've got lots of cubic centimeters. Oop, eraser. Bat, 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 error. I have 3,146 cubic centimeters. How many grams is that? So if you do this, you'll get a large number of grams. According to my calculations, X is 22,462 grams of zinc in the block. It'll also help if you label things with meaningful words. The bird itself, there's my bird, woo, 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 is 12,180 grams. The block of metal was 22,462 grams. So the difference between them is the shavings that Saeed can use to make hydrogen. So the difference here looks like 10,282 grams of zinc solid on the floor of the carving studio. That zinc will be used to make hydrogen. How do you make hydrogen? From zinc, react with an acid. You used hydrochloric acid in your Hindenburg lab. We'll assume Saeed has access to that, and he can make hydrogen gas like so. So this then becomes a stoichiometry problem with big numbers. I've got 10,282 grams of zinc. How many grams of H2 can be made? And I know from the balanced equation that 65 grams will get you 2. So this is a proportion with fairly large numbers, but it's easy to do. My calculations say that X equals about 316 grams of H2 gas. And then I need to say how many liters is that? That's where I can use the density of hydrogen gas. So that's another thing I would look up and find what is the density. It does depend on temperature and pressure, but this is a commonly used value for the density of hydrogen at standard temperature and pressure. And so I can use that to calculate the volume. Oh, I made another error. Look at me. It's not grams per cubic. It's not density per cubic centimeter. It's density per liter. Let's emphasize that. It's density per liter. And so the volume I'll get here is in liters, not cubic centimeters. And that turns out to be a large number of liters. I have 3,554 liters. That's huge, right? That is equivalent to 3.5 cubic meters. If you understand what that is, that's a huge, huge balloon. For question 2, you have to ask the right question. If we want to know how much volume of 6 molar hydrochloric acid needed, this is the question to ask. How many grams of actual HCl are in each liter of 6 molar HCl? That's the question you'd want to ask Google. It may be difficult for Google to give you an answer, so I'll give you an answer. It's 216 grams of HCl in each liter. The rest of the mass would be water. So I'll just say plus H2O. But we don't care about the H2O. It's not reacting. What is reacting is the HCl. You have 216 grams in a liter. It's use the balanced equation. That's all I'm going to tell you.